This is lesson 42 for 8th grade, and today we're talking about volume. Particularly, we're going to be talking about volume of rectangular prisms today. So we will get into the volume of other objects, but we're just sticking with pretty basic like cubic forms and rectangular prisms, which we'll see in a second here. But we want to relate volume to area, but realize that it's a different, it's not the same thing as area, and we'll get into why that is. We'll be going through that tomorrow. Okay. So in this lesson, we will find volumes of rectangular prisms. In later lessons, we will find the volumes and surface areas, so there will be a difference between surface area and volume of other geometric solids. So we will get into that, but we're going to start off with the easiest form of volume first. Alright, so the volume of a solid is the total amount of space occupied or enclosed by the solid. Volume is measured in cubic units, such as cubic centimeters, cubic inches, and cubic feet. The following diagram illustrates volume. Alright, so if we look at this rectangular prism here, we have the bottom layer of the solid has 4 rows of cubes with 5 cubes in each row. So 4 rows and then 5 cubes in each of those rows. Okay? And there are 3 layers of cubes because the height is 3 cubes tall. Okay? Alright, so there are 3 times 20 or 60 cubes in all. Notice that we found the volume by multiplying the area of the base by the height. And we can use this formula for any prism. And that's what we're going to relate to all the prisms that we deal with in this lesson and future lessons. So notice that if we were to find just the area of the base, that thing on the ground, we have a 4 by 5 base. So 4 and then 1, 2, 3, 4. So 4 rows by 5 rows. 1, 2, 3, 4, 5. 1, 2, 3, 4. So to find the area of that, that's 5 times 4, which is 20. But then we have 3 stacks of these. So we multiply it by 3, and we see we get 60 cubes in all. Okay? So 3 of those basically, and that's how we find volume, because it's about the amount of space a solid takes up. So let's kind of look at the difference here. Volume is in 3 dimensions. Okay, this has a width, it has a length, and it has a height. 3 dimensions. That's why whenever we work with volume, we're in cubic feet or cubic inches. 3rd dimension. So our units are to the 3rd power. Now remember when we dealt with area, we only had, let's say, square feet or square inches. And that's because it's a 2-dimensional thing. Remember we could find the area of a square. Okay? And that's because this has no height to it. It's just a square. It's 2-dimensional. It has a length and it has a width. Okay? That's why that is 2-dimensional, and that's the difference between area and volume. Okay, so volume of a prism, in the most basic form, is the area of whatever the base is times the height. So the base can be different shapes. Today we're going to deal with rectangles, and then we'll move into harder stuff as we go on. So more specifically then, for a rectangular prism, the area of a base is length times width for a rectangle. So that's the area of our base times our height. Okay? So let's use that real quick to figure this one out. Let's calculate the heating and cooling requirement for a room. One factor architects consider is the room's volume. A classroom that is 30 feet long, 30 feet wide, and 10 feet high contains how many cubic feet? Okay, well our base is a rectangle, and our height is 10. So we're going to use this formula, length times width times height. Our length is 30 feet, our width is 30 feet, and our height is 10. So we just multiply everything together, and we should get 30 times 30, 900, times 10 should be 9,000. And we are in volume, so we're talking cubic feet. So 9,000 cubic feet is what we should get for that one. Now that's a very basic volume question, but very applicable. Let's take a look at the next one. A sculptor carved a 2-foot cube of ice into a swan. At 57 pounds per cubic foot, what did the 2-foot cube weigh before it was carved? Okay. Alright, so we have a cube, and remember cubes have all the same side lengths, okay? So, I'll try to draw one as best as I can. Alright, something like that. And cubes have all the same side lengths, so we have 2 feet, 2 feet, by 2 feet. Alright? And it says 57 pounds per cubic foot. So what did it weigh before it was carved? So we're going to figure out how much this thing weighed. It's 57 pounds per 1 foot cube. Okay. So 1 cubic foot per 57 pounds. Now we're going to set up a little proportion here to help us figure this out. So we're going to look for this because we want to figure out how many pounds this will be once we figure out the volume of this, because where it says 57 pounds per cubic foot, and if we have 2 feet by 2 feet by 2 feet, the volume of this is length times width times height, 2 times 2 times 2, which is 8 cubic feet. Okay? So, we know the volume of this thing is 8 cubic feet. And notice how we have everything lined up. Volumes across from each other, and then pounds would be across from each other. Because we're trying to figure out how much it weighed, or how many pounds it was. So, what we can do is cross multiply, divide, 57 times 8, and then divide by 1. Or, in this case, just 57 times 8. Because if we divide by 1, we'll get the same answer. Or we can see that to get from here to here, we just multiply by 8. So we just multiply 57 times 8. So let's do that. 8 times 7 is 56. 8 times 5 is 45, or 40, plus 5 is 45. So 456 pounds, that's what X should be. Pretty big, pretty heavy. Alright, that's what we should be looking at for that one. And we've got one more to take a look at. See how much time I've got left. We're doing fine. Okay. Okay, this is probably the most challenging problem that we'll run into today because we have a prism, but it's kind of an irregular one. So it says, many buildings and other objects are shaped like a combination of geometric solids. Find the building, or find the volume of a building with this shape. All angles are right angles. So we are dealing with prisms here, and here's what I say we should do. We want to figure out, let's just kind of chop this up a little bit. Let's try to figure out this volume right here. So we've got our red cube, or it's not necessarily a cube. We've got our red prism. we'll figure out that volume. And then we've got our bigger prism, this one right here. So we'll draw that one out too. Not the best, but you know what I mean. Okay? So let's figure out these separately. Alright. Yeah, definitely not my best, but it looks okay. So just looking at, let's figure out the red dimensions here. Looks like our base is a 12 by 12. And our height, this right here, is 10, because that shows us our height. Everything's the same height, so we've got that. So before we even move on to the other prism, let's figure out the volume of this one. It's a prism, so we go volume equals length times width times height, 12 times 12 times 10. 12 times 12 is 144. And then we still have times 10. 144 times 10 equals 1,440, and we are in cubic feet. Alright, so we have this volume figured out. Now all we have to do is figure out the other volume. Let's figure out our dimensions here. We're dealing with this big one now, so we're looking at this, this, okay. Now, what we really need to figure out here is, yeah, I'm gonna erase that, but you know what I meant, it would go through there. We have to figure out our long dimension here. It looks like this part, we know that this is 10 right here. And that this part should be 20, that's right here. But what is this long part going to be? That would be this line right here. What is that going to be? Well, this is 15, so that would be from here to here is 15, and then from here to here, that should be 12. So 15 plus 12 is 27. And that's the tricky part of this one. Figuring out that front dimension or the other dimension. So we did this 12 plus this 15 to get that line right there. Alright. Now we just have to figure out the volume of this one. So a prism once again, and it's a rectangular prism, so length times width, area of the base, equals length is 27, width is 20, height is 10. So we have 27 times 20 times 10. I'm going to take the shortcut on this one, use my calculator. Save time. 5,040 or 5,400 it looks like. And once again, cubic feet. Okay, we're not done though because it wants the full volume. So we're going to add this together with this, and that should give us our final answer. So 1,440 plus 5,400, and we should get 6,840 cubic feet. Looks like we got it right.